last time we talked about linear regression, and I want to emphasize one point from that. Linear regression uses a line to solve things, specifically a line and nothing else. And so I want to give you the example that we had last time, which was there is time on the x-axis and then the pollution on the y-axis. And then there is another example for to show you, which is like time and then let's say temperature. Let's say over time, maybe the temperature is steadily increasing as well. This is a fictional example, but can be attempted using linear regression. Another fictional example is, let's say, time. This could be time throughout the year or whatever, but basically rainfall. Rainfall in inches. Okay. So we have a couple of examples here, and they all fall under linear regression. And by falling under linear regression, I mean that we can use linear regression to solve them, not that linear regression is the only way to help solve these problems. And what is common to all of these problems? I want to point something out to you. So the amount of pollutants in the air, that is a number, right? So let's say like the PM 2.5 levels um, could be like 40 parts per million, or they could be 100, or they could be 101.5 or something like that. I'm making these numbers up, but the point is that they're continuous. They're what we call continuous, right? And effectively, they can take on any value, potentially from negative infinity to positive infinity. It's not physically possible, but theoretically, this is the model that we're making. So, for example, temperature can go up to infinity technically, and rainfall in inches, right? The amount of rainfall in inches throughout the year, that is also continuous. It could be anywhere from like 1 inch to 1,000 inches, which would never happen. But I just want to point out that these are all continuous values that can sort of range from negative infinity to positive infinity, right? And so I want to present a new type of problem to you, and that is not the amount of rainfall, but is rain going to fall? Um, Rainfall question mark, right? Is it going to fall or not? Not the number of inches. No, not the amount of rain that's going to happen tomorrow. I want to know, um, is it going to rain tomorrow? Yes or no? And so this is a little bit more confusing because this can't technically range from negative infinity to positive infinity. This can only be 0 or 1. Let's say we say like no is 0 and 1 means yes, right? You can only answer as one or the other, right? And so how do we create a model that only gives one or the other, right? For example, one thing we could do is let's say we have um, let's say we have time here and rainfall question mark here, and this is 0 and this is 1. And so throughout time we'll just label, okay, at time 0 there was rain, and then there wasn't rain, and then there wasn't rain, and then there was rain, and then there was rain. So we could do something like this and try to fit linear regression to it, but it doesn't make any sense. So I want to maybe one thing we could do to adjust that is when we do y equals mx plus b, what we could do is if y is greater than or equal to 0, then say yes, rain will fall. And then otherwise no. Right? This could be a rule, right? So that gives you only two answers. So if your linear regression outputs like a positive number, then you predict 1. If it outputs a negative number, you predict 0. I want to give you a little bit more sophisticated way that you sort of do this in what's called logistic regression. But in a second, like I'll do that in a second, because first what I wanted to show you is I want to review this example over here. So this was linear regression, and then this is a fundamentally different problem. So I wanna make it clear that this problem is called classification. And this problem over here is not actually linear regression. Linear regression is a tool. I want to make sure you know that this is just called regression. Uh, and broadly speaking, regression basically means that your output can have any number of examples, and it can be continuous, sort of. And it's sort of along the lines of that it can range from negative infinity to positive infinity. Not always, but that's usually what it means. And classification means that you have a finite number of things to choose from, such as this example where it's yes or no. Uh, Other examples might include that there could be, three different options or 10 different options, or even 100 different options or 1,000. But there's always a finite number of options. You can't have something in between 10 and 11 options, for example, in classification. So that's what I wanted to make clear to you right now. And so in the next video, I'll tell you about the more sophisticated tool that you use to transform linear regression and use it as a problem-solving technique for classification problems.